This is a video lecture going over dimensional analysis. And before we go into dimensional analysis, which is basically a way of using units to figure out what answer you want. Before we get into that, we're going to do a really quick algebra review. So some of the basic algebra concepts that you need to know include something like division. So something like 5 divided by 5 equals 1. And so this is the same as saying something like 5 times 1 over 5 equals 1. And so here the 5's can cancel out because 1 is in the numerator and 1 is in the denominator. And so this will translate to having units where something like meters divided by meters equals 1, or meters times 1 over m equals 1. So the units will still cancel out here. Something else that might get a little bit more complicated is if you have something like meters squared divided by meters, and that's going to give you just meters, or meters squared times 1 over m is still going to give you meters because the meters cancels with the 2 meters, the meter squared there. And so that's kind of the basic algebra behind what we need to do specifically for the units. And so let's do an example where I'm just going to list what you need to, what information that I'm going to give you, and then we are going to, and I'm going to tell you exactly what you need to figure out. So let's say the flux of the sun is 6.3 times 10 to the 7th watts per meter squared. Okay, and the surface area of the Earth is, sorry, not the surface area, but the area of the Earth. So let's just scratch that out. The area of the Earth is 2 times 10 to the 7th meters squared. So to remind you, something in meters is distance. Something in meters squared is an area. And something in cubic meters is going to be a volume. So what we have here is an area. And so I want the final unit in watts. And so how many watts of energy reaches the Earth? And so my final unit that I want is watts. So let's look at what we have. So we see that we have watts up here, and we want that to be remaining, but we want to get rid of the meters squared. So in order to do that, we need to multiply these units by something so that the meter squared is canceled. And so we have meters squared here, and so we're going to multiply the 2 in order to get that meter squared to cancel. So we're going to start with 6 point, oops, let's try that again. So we're going to start with 6.2, or 6.3 times 10 to the 7th watts per meter squared. And I'm going to multiply that by my area, which is 2 times 10 to the 7th meters squared. And so you see here that the meter squared is on the top and the bottom, and so they're going to be able to cancel. And if I put this in the calculator, it is going to give me 1.26 times 10 to the 15th watts. And we know that this is watts because that's the unit that I have left. So here I gave you everything you needed and I listed everything instead of having it written in a word problem. But whenever you do have a word problem, it's really helpful to list everything, all of the information that you're given, and to list what unit is your final goal. And so let's where I give you a word problem and you need to pick it apart. And so the specific heat of water is 4,218 joules per kilogram Kelvin. The density of water is 1,000 kilograms per cubic meter. The body of water has a volume of 400 meters cubed. Calculate the heat capacity of the water in units of joules per Kelvin. So I always like to start problems by just listing what I have because it's just so much easier to absorb as opposed to continually looking back at the word problem itself and trying to figure out what units I have and what I'm still missing. And having a list makes it a good checklist so you can kind of check off what you use as you go. And so I'm going to start by listing what I have. And so what I have for these knowns is, I know that I have 4,218 joules per kilogram Kelvin. I know that I have a density of water of 1,000 kilograms per cubic meter. And I know that water has a volume of 400 cubic meters. And so what I want to calculate is the heat capacity. So I'm looking for this heat capacity and it has units of joules per Kelvin. So heat capacity equals what? And it's going to be in units of joules per Kelvin. And so these are my knowns. I'm going to put that aside and look back on it as I go. Okay, so let's figure out exactly what we need. So we're looking for joules per Kelvin. We have joules per Kelvin in this unit here. So we want to keep this, but we want to get rid of the other thing in this set of units, which is kilograms. So we're going to start with 4,218 joules per kilogram times Kelvin. So again, we want to keep the joules per Kelvin. Let's get rid of, so I've used this piece of information. Let's get rid of that kilograms first. And so which piece of information has kilograms? So this piece of information has kilograms. So I'm going to use that next. And I want kilograms to cancel. So if kilograms is on the bottom over here at what I've written down for my equation so far, we want the next kilograms to be on the top of the equation so that they can cancel. So one on the bottom and one on the top allows them to cancel. So we're just going to multiply that. So I've used that second piece of information and we see that kilograms can cancel. And so we have, we still have our joules per Kelvin, but we now need to get rid of meters cubed. And so my last piece of information, so I'm keeping track of these, and now I'm using my last piece of information, which is 400 cubic meters. And so now we can see that those cubic meters will cancel, and I'm just left with my joules per Kelvin. And so if I put this in the calculator, it's going to be 4,218 times 1,000 times 400. And that should give me 1.69 times 10 to the 9th joules per Kelvin. Okay, so that's one problem. Now we're going to do another one where we actually have to take the reciprocal of these. And so to kind of quickly review, if 5 over 5 equals 1, then if I flip these, because 5 over 5 is the same thing, I can flip those and put the bottom 5 on top and put it on the bottom because they're equivalent and they're still going to equal 1. And so let me just erase that real quick. So let's start this next problem. So I'm going to start it again by listing what I know and what I need to figure out. So if the heat capacity of a given volume of water is 1.69 joules times 10 to the 9th joules per Kelvin, and water has 500 joules of energy, what is the temperature of water? So I'm going to list my knowns, and I have 1.69 times 10 to the 9th joules per Kelvin. And I also have 500 joules of water. I'm looking for temperature, and that is going to be in Kelvin. So again, I started by listing my knowns. So now I'm going to go into the problem. So I want to find temperature, which is in Kelvin. And so Kelvin right now is at the bottom of this fraction, but our final answer is going to be Kelvin. So we want it at the top of the fraction. So we're just going to take the reciprocal of this. So 1 Kelvin divided by 1.69 times 10 to the 9th joules. So we took the reciprocal of that because the 1 Kelvin and the 1.69 times 10 to the 9th joules are equivalent. So we can have the Kelvin at the top of the fraction. So we've used this first piece of information. Now let's use the second piece of information to get rid of our joules because we want Kelvin at the end of the day. So we're just going to multiply this by 500 joules, and we've used our last piece of information. And so this is going to end up being, when we put it into our calculator, 500 divided by 1.69 times 10 to the 9th. And my final unit, once the joules cancel out, is going to be Kelvin. And this gives me 2.96 times 10 to the minus 7th Kelvin. And so that concludes this video lecture. I will post other practice problems for you with answers, but this should help you get started.